All right, so let's think about this. So what we did is we started here. We started with this little green box, and then we transformed it to A, then transformed it to B, then transformed it to C, then D, then E. Well, what we noticed is that the shape was the same. In other words, it was always a rectangle. The final image, which was E, was 3 times larger than the original image, and that the angles were the same. So we have some reflection questions. It says, which transformation represents the dilation? How can you tell? Well, that's this one, the one that said X, comma, Y is transformed by 3 times X, right? You could do better on that X, I think. Times 3Y. And we would say K, the scale factor, is equal to 3. Okay. Part 2, or question 2, it says, a sequence of transformations containing a single dilation is applied to a figure. Are the original figure and the final image congruent? Explain. No. They are similar, though. Similar just means that they have the same angles, which should, in all, for most intents purposes, leave it the same shape. It's just that it's bigger now. Oh, I should probably put the word are. So they are similar. Now, you can't be similar or congruent. Did you say they similar? That's funny. They can't be both. They have to be one or the other. So anytime you have a dilation, it's going to be similar, because the dilation, unless K equals 1, and that's not really a transformation, right? It's either going to be bigger or smaller. Remember, congruent means same size, same shape, same angles. So for example number 1, what they want us to do is identify the sequence of transformations that will transform figure A into figure B. Well, there's a dilation that's taking place for sure. And maybe some sort of translation. So what you could do is, I'm just guessing, and they probably say this in the words, I'm guessing that there was a transformation. So see how this square is 4 units by 4 units, and this one's just 2 by 2? Yeah. So I'm going to try and make one that's 4 units. So I'm guessing that this was constructed. That's a dilation, right? And then it was just moved. Well, how far was it moved? Well, to get from one corner to the other, from this corner, I go 1, 2, 3. Wait, let me count. 1, 2, 3. Let me zoom in a little bit so we can get a better picture of this. So from here to here, I've got 1, 2, 3, 4. So that's 4 units to the right, and then I went up 1, 2, 3, 4, 5, 6. 6 units up. And this point here is 1, 1, so this point here is 2, 2. So I suspect that we did a dilation first. I'm going to read what they said. Of 2 times X, 2 times Y. And then we did a translation where we went 4 units to the right. So it would be X plus 4, up 6 units. So that would be Y plus 6. So let's read what it says. It says both figures are squares whose orientations are the same. So there is no reflection or rotation needed. Figure B is twice as long as figure A, so the dilation is a scale factor of 2. That's what we said, right? Scale factor of 2. B is then moved 4 units to the right and up 6 units. That's what I said. Okay. So now for part B, it says identify the sequence for these transformations that will transform figure C into D. So I think you have to reflect it first, and then you have to make it bigger. Wait, did they say go from C to D? Okay, so this is our pre-image. C is our pre-image. So the first thing that you need to do is you need to half it. So you have a scale factor of 1/2. Then you need to reflect it across. So let's do that. Let's put down what we're doing. We're doing a dilation. We did a dilation. And you say, Mr. Adams, how do you know it's 1/2? Well, look, this length right here is 1, 2, 3, 4. The length of this is 2. So it's 1/2 times x, 1/2 times y. Then the next thing we need to do is reflect it across the y-axis. So remember that to reflect it across the y-axis, you're going to negate the x's. So this becomes a negative x, comma, y. So the y values stay the same. And then lastly, when we do that, it's got to shift up 1. Well, it'll end up being here, so it'll go up 1, 2, 3. So then we'll have x comma y. I'm guessing that we go up 3. So that would be x comma y plus, oh no, it's 5 actually. Not 3. It's 3 from the old one, but when I shrink it, it's actually 5. And that's what they say. Scale factor of 1/2. Negate the x because it's reflected across the y-axis. Then we shift it up 5. And then they explain it more using words. I encourage you guys to read that, but for time's sake, we're just going to go through this. It says, look again and explore activity. Start the original figure. Now consider a new sequence of transformations your transformations do not need to produce images in the same order as they originally appeared. So what they're saying is, how would I do this over? They're talking about example 1. What would I do to get this here as E? Well, you could do a rotation of 90 degrees. There's lots of things. So I'm just going to say that the answer will vary. I'll write a sample example down though, but you could say that maybe you go x comma y. Maybe you shift it over so it's x plus 7 comma y minus 12. So now if you did that, you would take this image way up here and you would go plus 7, which would move it here, and then down 12, which would put it here. And then you would rotate it probably 90 degrees, right? So then you would rotate it 90 degrees. Clockwise. And then lastly, you would say x plus 5 comma y plus 3. And then, and what that does is that shifts it up. Basically what we're doing is we're moving it right here. So what they're saying, when I move down 5, when I move over 5 and down, what did they say it was, 3? No, we're going to move over 7 and then down 12. So that would mean I go from here. I go 1, 2, 3, 4, 5, 6, 7. Then I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That gets me to B. Then when I rotate it, basically we're bypassing A. Then when I rotate it 90 degrees, that gets me to C. Then we transform to D. And then lastly, we just need to multiply by 3. So we just skip the A. And then we said that xy would equal 3 times x, comma 3 times y. And they just skipped A. Okay. Are there any questions on that?